Hello friends, welcome to my workbench. I am Jyotirvid Pavan Kumar. In this video, I would like to describe how to make a compact night lamp using LED, and most of the components I am using from a discarded CFL compact fluorescent lamp like this. So usually what happens, you get guarantee for a year on this, and after the warranty is over, then if it is fuse or there is some fault, it doesn't glow, then usually people throw it away. But if you are a electronic hobbyist enthusiast, then you must keep it, because there is a circuit inside using plenty of electronic components which you can use in electronic projects. Like I'm using a lot of components from discarded CFL for making a mains run night lamp using LED. Now, first of all, when you have this discarded CFL, they come in different sizes. Doesn't matter. There's a circuit inside. Now, you have to be careful in order to open it, because this portion is glass, so you can injure yourself. So taking good care, you can use a screwdriver, and there is a joint here. This line, the upper portion, the glass portion, is joined to the lower base, so you can keep a screwdriver here, and using a hammer you can just hammer it a little bit down, and then if with a little practice you will be able to open it up like this. I have opened already just to show you. And then when you open it up, the first thing you must do is take a cutter, wire cutter, and cut the wires so that you can keep this glass portion away, because you don't need it. Now inside there is a PCB with plenty of components, and what you can do is you can cut the wires again using your cutter, and you don't need this housing, so you can keep it away. Now this is a complete circuit which was running your CFL, and usually the components are not faulty, and you can find out. Now first of all, I must show you the circuit diagram which I am using for this project. Here is the circuit diagram. We have 230 volt mains AC voltage which is coming in the mains supply. Now we need to reduce this voltage, so for that we are using a capacitor, a polyester capacitor. Now this capacitor which I am using, this is 0.22 microfarad, 400 volt, and I have taken this out from a discarded CFL. It could be in different color, but I am using 0.22 microfarad which I found in discarded CFL. You can use anything from 0.1 microfarad to 0.47 microfarad. The higher the value, more voltage you will get here, but 0.22 microfarad is sufficient. Now the values written on the capacitor, you need to learn this. If you look at this, this is very fine writing, and it is written 220 . 220N. On some capacitors you may find 224K. So both these are same and they mean 0.22 microfarad. If it was 0.47 microfarad, then it will be written as 474K or 470N. They both mean same thing, which is 0.47 microfarad. But in the CFLs which I have opened, I find 224K, which is 0.22 microfarad, and that is fine. Now this capacitor, which I have shown you, is a polyester capacitor, and it will be connected to the AC power supply. So you don't need to bother about the polarity. You can connect it anyway, this way or that way, doesn't matter. Then looking at our circuit diagram, I have connected a resistor R1 across this capacitor C1. Now the purpose of this resistor is when you are connecting the circuit to supply, this capacitor will charge up. Even after the supply is turned off, the charge stays on the capacitor for a certain time. So in order to avoid that, so that you don't get a shock if you open up the circuit and touch it, we are connecting a bypass resistor R1. You can use any value from 100 kilo ohm to 1 mega ohm, but I am using 510 kilo ohm only because this is available in the CFL circuit. So this resistor is here, and the capacitor was here. So we collect this. Then we need to turn this low voltage to DC. It was AC here, even up to this point. Now we need to turn it to direct current, DC voltage. For that I am using a bridge rectifier using 4 diodes, D1, D2, D3, D4. Now you can use diodes 1N4001. No, I'm sorry. You must use at least 1N4004. I will tell you the difference. But in CFLs I find 1N4007, which is much better. The difference is in the safe reverse DC voltage, which can be there across this capacitor before it is burnt. So 1N4007, which is available in this CFL circuit, is quite good. So I'm using that. But if you are purchasing from market, then go for 1N004 or 1N4007. Now these diodes, they look like this, very small, and there is a white band across this diode on one side, which indicates the cathode. The other side is anode. So we need 4 of these. I have these 4 here. Then after that we get low DC voltage at this point with respect to this negative, and I'm using a resistor, series resistor R2, in order to limit the current which will flow through the LED. So I am using 33 ohm. You can use other values, 47 ohm, which will give slightly lesser current, but I am using 33 ohm half watt because this resistor is available in this CFL circuit. So this is fine. Then at this point we get DC like here, but there can be a little bit AC also ripple on this. So in order to smooth it or filter the AC part, I'm using a electrolytic capacitor which is polarity sensitive. The positive is connected to the positive side, negative to the negative line. I'm using 100 microfarad 25 volt. Now this capacitor is not this value or any value near this value is not available in the CFL circuit, so you have to purchase. But I took out this capacitor from another discarded electronic item, so you can do that. You can use even lower values, but it should be at least 47 microfarad or more, so I am using 100 microfarad. Then this is the LED. The symbol indicates LED light coming out. Now this LED, I am using a bigger LED. LEDs come in usually in many sizes, but in round shape there are 3 mm type and 10 mm which I am using. So this one you have to purchase from electronic component shop. So in addition to this, while making this project, you will need some hookup wire. This hookup wire you can purchase from some electrical shop, and you need 3 pieces of approximately 2 to 3 centimeters. Now I'm not telling you how long the pieces should be, because I don't know which type of plug you are going to use, and you can cut the wires as required. Now after you cut the wires, you can strip the insulation, and it is always better to solder the wire, the copper wire, so that later you get a good solder joint. So you can use a soldering iron like I'm using here in order to tin it. So you can tin it. Now later when you connect it to the circuit, it will be easy to solder the wire to the circuit. Now in another video I have already demonstrated how to make good solder joints. You can watch that video. You can keep a sponge. This is a natural sponge, not synthetic one. This is soaked with water, and you can clean the tip of the soldering iron in between your soldering. This will improve your solder joints. And for making the joints you need a solder wire. Always use a solder wire of good quality, and the one of good quality is shining, not dull when you look at it, and it should be 60-40. Now 60-40 means 60% tin and 40% of lead. If it is other way around, then that is not a good solder wire. And for tools you need a screwdriver, wire cutter, and stripper like this. It is both. It cuts the wire, it strips the insulation also. And I have a multimeter with me. If you are a hobbyist, this is very useful. I will demonstrate. And the soldering iron should be there. Then you need a source of mains power supply in order to test your circuits, but always be very careful while working with the mains AC supply to prevent shock. And the best way is you sit in a way so that your feet do not touch ground or wall. And always, if the circuit is live, if you touch with both hands, then you are bound to get a shock. So the best thing is always use one hand to touch any part if the circuit is live, but do not do that. Now In order to fit all these components after soldering inside a 2-pin plug like this, you need to select a 2-pin plug. Excuse me. You need to select a 2-pin plug which has more space inside. So you can go to an electrical shop and you can look at the various brands, and this one is no good because it is smaller inside, and this hole where the LED is to be fitted is not sufficient. So I have selected this one. You can purchase this. This is very cheap. Now I will show you. If you open it up with a screwdriver, now inside there is sufficient space, but still these plastic walls are there. Actually these are there just to keep the wires in place. Excuse me, I'm not feeling well, so excuse me for the cough I'm suffering from. You have to remove this wall on both sides. So for that, use your cutter very carefully. You can cut it and remove this. So I have already done that with the portion with the plug I am using. So I have removed the plastic walls here. Leave this in the center because the screw will be fitted here. And also, in order to fit the LED, which will be visible from outside, you may need to scrape a little bit of plastic very carefully using a knife. Scrape it like this so that your LED fits. So always purchase this 2-pin plug with a bigger hole. Now if by chance you don't get this and you get a plug which has enough space inside but the hole is smaller, you can use a 3 mm LED. Sorry for that. So I have shown you how to open up the discarded CFL. Now I'll show you all the components. This capacitor, polyester capacitor, is this one. This is 0.22 microfarad. The resistor across this capacitor R1 is inside. You may not be able to look at it. This is inside. And then these 4 rectifier diodes, these are here. One is here, and 3 diodes are here underneath the polyester capacitor. So using a soldering iron, you can remove this. You can watch my other video which is there, which will help you to learn how to remove components from PCBs. And then this resistor 33 ohm half watt, it is also there in this circuit. And these two components, electrolytic capacitor and LED, which I have told you already, you will have to purchase these. So this is the circuit you can note down. Now let us get on with the project. Now this is one compact night lamp circuit which I have fitted in a 2-pin plug is already there. I have made it. I'll show you. You can see how so many components. So you have to solder all the components as per the space available in the 2-pin plug. So you have to use a little bit of ingenuity and skill, which can come with practice. These are the 4 diodes. This is the series polyester capacitor, and these are the 4 diodes. This is LED. This is electrolytic capacitor, 100 microfarad, and this resistor is 33 ohm series resistor, which was I showed you in order to limit the current through the LED. And across this polyester capacitor there is a resistor, and I'm using 510 ohm, 510 kilo ohm, which is available in the CFL. Then you use these wires, yellow wire, this one for AC, and you can screw these in the 2-pin plug screws. And I'm using a black wire, which I showed you, this one. You can use any color, doesn't matter, for the negative portion, and for the positive you don't need because the components are directly soldered. You can look at it very carefully, but you need some skill and ingenuity to place the parts and solder these so that the circuit is compact as per the space available in the 2-pin plug which you have selected. But you can see I have done this, so why can't you do it? And then you place it like this inside, and the center portion is clear so that the other part will rest on this and the screw will go through. LED is coming out from this in order to give light, so then you can press down the other portion and you can screw it up using nut and bolt which comes with the plug. So your compact 2-pin plug, night lamp, LED lamp, mains operated, is here, is ready. So I will show you, I will light it up for you. This LED I am using, there are LEDs available with different colors of light. I am using a warm white, which is more like daylight, slightly yellow. You can use any color. Now when you switch it on, it gives plenty of light. You may not be able to see a lot of light because I'm already using a lot of light for this video, but you can see when you light it in a dark room, you will get plenty of light. It is quite bright. Now let me tell you a little bit more if you are interested. If you are a student and electronics is your hobby, probably you know it, but for those who do not know it, let me guide a little bit more about the components. Now this capacitor I told you is polyester capacitor. Now it is not polarity sensitive, you can connect it anyway. This is LED. Now LED is polarity sensitive, and LEDs can get damaged very easily if you connect reverse voltage across it. That means, now this is anode. Excuse me for coughing, sorry for that. Now this is a symbol electronic symbol for LED. These two arrows show that the light is coming out when it is connected to supply. This is A, anode, and this part with the line is cathode. This is to be connected to the negative side, this to the positive side of DC supply. Now there is a forward voltage drop on the LED which differs from LED to LED. LEDs of different colors, they have different forward voltage drop, which is around 3 volts. The one which I am using, warm white, has about 3.1 to 3.2 forward voltage drop. Now this LED, when you purchase from market, right, you get LEDs with the colored glass also, but I prefer the ones with clear plastic. Now they all look same, but when you connect it to the supply, they give color as per their manufacture, their type. Now when you purchase it from a component shop, it has two leads, and one lead is longer than the other. This is just to differentiate between the polarity. The longer one indicates anode, positive terminal, and the shorter is cathode. Now just by chance, I had a LED lying in my components which had equal length of both leads. So how to check? Because what happens if you connect the LED wrong way round across a supply greater than 3 volts? Sorry for that. Again, I'm not feeling well. Then how to check the polarity before you connect it to the circuit so that the LED is not destroyed? For that, there are two ways. One is I have this lithium 3 volt button cell battery which is used in calculators and other electronic gadgets. Now this one, if you are interested, I can tell you, this one is a CR2032, but you can use any lithium cell of even of different number, and this should be 3 volt. So if you connect it, this is a positive side and this is negative. So if you connect the positive to the anode and negative to the cathode, the LED lights. Now since this voltage coming out from this lithium battery is only 3 volts, so if you connect it the wrong way round like this, it won't damage because the voltage is low, right? So this is a safe way. You can do that if you're a hobbyist. And the other way is if both the leads are confusing, they are of same length, then if it is a clear LED, you can easily look inside, and if you carefully look inside, you will find that one terminal is flat, longer horizontally than the other, like I've shown in a diagram sketch which I have drawn. This is a bit longer horizontally and the other is shorter. The shorter one is anode usually, and this bigger one is cathode. So you can use this method to differentiate between the leads, and this information may help you. Now another information, if you are electronic hobbyist, you are a student, you are interested, then probably you know all these things, but there's a Ohm's law and you can calculate the current. Like in this circuit I have calculated, I is the current, DC current, which is voltage divided by the resistor, value of the resistor. Now in my circuit I get I get about, I haven't written here, but it is about 3.66 if I remember volt here, and 3.1 volt here. So the difference between the voltage here and here is 0.57 volt. So you use your multimeter, check the voltage here. You will have to use the setting of the multimeter for DC voltage. You turn it to 20 volt DC, and you connect one positive lead to this point and negative to this point in the circuit, and you see the voltage here, which in my case was 3.67 if I remember, and voltage here across the LED, it can vary as per the color of the LED, but the one I am using is 3.1 volt here. So the difference between the voltage here and here is 0.57. Divided by this resistor, value of the resistor, which is 33 ohm, I get 17.27 milliampere. So that is the current which will flow through your LED. So this is sufficient. More than 15 milliampere is sufficient to give you light. You can get more light by, there are two ways. You can increase the value of this AC voltage dropping capacitor, polyester capacitor, or you can reduce the value of this series resistor. But I am using 33 ohm since it is available in the CFL circuit. So my idea for this project was how you can utilize discarded CFLs. Now you can calculate the wattage of this resistor. Wattage is equal to voltage multiplied by the current. This is voltage is 0.57 multiplied by, now this is 17.27 milliampere. If you write in terms of ampere, so it will be 0.017. So multiply these two, you get 9.84 milliwatt. So this resistor of half watt, which is 0.5 watt, is much more than the required, right? So your circuit is quite safe. Now another thing which I have already told you, these rectifiers, the rectifier diodes which I have removed from CFL, these are 1N4007. If you are purchasing from market, then go for 1N4004. The difference is only in the reverse DC safe voltage which can appear across the diode before it is destroyed. So for 1N4004 it is 400 volt, and for 1N4007 it is 1000 volts. So the rectifier diodes you are getting from your discarded CFLs are much better. All these diodes 1N4001 to 7, all these are capable of giving you 1 ampere of current. So it is quite good. These are called rectifier diodes. So I hope you enjoyed watching this video, and if you like this video, give your comments, good or bad, whatever. All comments I always welcome, but use a decent language. Some people, especially from foreign countries, they use very filthy language. They abuse. Well, if you do not like any video, just say so or don't watch it. But why to use filthy language? So I hope if you're watching this video, you are a sensible person, a learned person, and I don't expect any bad language from you, because it is going to appear, your comments are going to appear on YouTube, which is very important, a very popular forum. So boys and girls throughout the world watch, so we must use decent language as used by gentle people. If you like this video, let me know so that I produce more videos like this. And if you like me to produce a video on a particular topic, then you can let me know. Thank you for watching.